Hello and welcome to this video. So a special welcome to those who are new to the channel. If you are new to the channel, please make sure that you subscribe to the channel and press the bell icon so that you can get notification about the latest videos of the channel. So in this video, we will study 33rd set of problems on complex numbers. Now these problems are slightly more involving, so I will slow down a tad so that I can explain it in more these problems in more detail. As always, I will repeat that when I am stating the problem, please pause the video and try to solve the problem yourself. Only if you cannot solve the problem yourself, then look at the solution. So without further ado, let's get started. So question 311 says that if 1 plus x to the power n is equal to p0 plus p1x plus p2x square plus pnx to the power n, show that p0 minus p2 plus p4 minus so on is equal to 2 to the power n by 2 cos n pi by 4, and p1 minus p3 plus p5 minus so on is equal to 2 to the power n by 2 sin n pi by 4. So we have this given equation. We substitute x is equal to I. We get 1 plus I to the power n is equal to p0 plus p1i plus p2i square plus up to pn I to the power n. So clearly p2i square will become minus p2, p4i4 will become plus p4. So that is the real part of this, and pi will remain pi cube will become minus pi to the power 5 will become plus p5i to the power 5 will become p5i. So this is the imaginary part here. Now this 1 plus I whole to the power n can be written as square root of 2 cos pi by 4 plus I sin pi by 4 whole to the power n. If you don't know how to arrive this, what you should do is you look at the modulus of this complex number. Modulus is square root of 2. You take that out, you will get 1 by root 2 plus I into 1 by root 2. Now 1 by root 2 is nothing but cos pi by 4 and sin pi by 4. So that's how you convert complex number into polar form. From Cartesian form, you convert it into polar form. Now this is equal to this, that is p4 p0 minus p2 plus p4 and so on, plus I p1 minus p3 plus p5 and so on. Now it is all a matter of equating real and imaginary parts. Now note that when you take out this n, you remove this power n, 2 to the power half is here, so it will become 2 to the power n by 2. Cos theta will become cos n theta, that is cos n pi by 4, and I sin pi by 4 will become I sin n pi by 4. So that's how we arrive at the required result, which is p0 minus p2 plus p4 and so on is equal to 2 to the power n by 2 cos n pi by 4, and p1 minus p3 plus p5 and so on is equal to 2 to the power n by 2 sin n pi by 4. Question 312 says that if 1 minus x plus x square whole to the power n is equal to a0 plus a1x plus a2x square plus up to a2n x to the power 2n, show that a0 plus a cube a3 plus a6 and so on is equal to 1 by 3 into 1 plus 2 to the power n plus 1 cos n pi by 3. So to solve this problem, we put x is equal to 1 omega and omega q in the given equation, that is this equation. So when we put 1, it becomes a0 plus left hand side becomes 1, because 1 minus 1 plus 1 square, that is equal to 1, and the right hand side becomes a0 plus a1 plus a2 up to a2n. When we put omega, this would be 1 minus omega plus omega square, and 1 plus omega square is equal to minus omega. So minus omega and this minus omega, that will be minus 2 omega. So minus 2 omega to the power n is equal to a0 plus, this should be a underscore 1. This is a subscript, a1 omega plus a2 omega square up to a2n omega to the power 2n. And similarly, when we substitute x is equal to omega square, this will become 1 minus omega square plus omega to the power 4. Now omega to the power 4 is omega, so 1 plus omega is equal to minus omega square. That when combined with this omega square will become minus 2 omega square. So minus 2 omega square to the power n is equal to a0 plus a1 omega square plus a2 omega square up to a2n omega to the power 4n. Now we add these three. So you see with a1 we will have omega here and omega square here. So 1 plus omega square, that will become 0. a2 will have omega square here and omega 4 here, that is omega. So a2 will become omega. a3 will have no problem with this. So a3 will be here, a3 omega cube, that is a3, a3 omega to the power 6, that is a3. So it becomes 3a3. Similarly, a6 will become 3a6, a4, a5 will become 0. So adding, we get 3 into a0 plus a3 plus a6 and so on is equal to 1 plus minus 2 to the power n, minus 2 from here, minus 2 from here, minus 2 to the power n omega n plus omega to the power 2n. Now we know that omega is equal to minus half plus square root of 3i by 2, that is cos 2 pi by 3 plus I sin 2 by 3. So omega to the power n is cos 2n pi by 3 plus I sin 2n pi by 3, and omega square is equal to minus 1 minus root 3i by 2, that is cos 2 pi by 3 minus I sin 2 pi by 3. So omega n plus omega to the power 2n is equal to 2 cos 2n pi by 3, which is equal to 2 cos n pi minus n pi by 3. So this is equal to, sorry, there is a mistake here. So no, there is no mistake. This is equal to 2 into minus 1 to the power n cos n pi by 3. Okay, so now this becomes equal to 1 plus minus 2 to the power n, this value, into this value, that is 2 into n minus 1 to the power n cos n pi by 3. So minus 1 to the power n and minus 2 to the power n becomes 2 to the power n, into 2 is 2 to the power n plus 1, and into cos n pi by 3, and thus we deduce our required result. Question 313 says that if n is a positive integer and 1 plus x to the power n is equal to c0 plus c1x plus c2x square plus up to cnx, show that c0 plus c4 plus c8 up to and so on is equal to 2 to the power n minus 2 plus 2 to the power n by 2 minus 1 cos n pi by 4. So we have this equation. So we put x is equal to 1 and x is equal to minus 1, and we add. When we put x is equal to 1, it becomes 2 to the power n is equal to c0 plus c1 plus c2 up to cn. And when we put x is equal to minus 1, it becomes 0 is equal to c0 minus c1 plus c2 up to minus 1 to the power n cn. So we add this with this, and we get 2 to the power n is equal to 2 into c0 plus c2 plus c4 and so on. That is c0 plus c2 plus c4 is equal to 2 to the power n minus 1, because we divide from 2 here, that is we divide 2 to the power n from 2, so we get 2 to the power n minus 1. Now we put x is equal to I, so we get c0 plus c1i plus c1i c2i square plus c3i cube and so on, that is equal to square root of 2 cos pi by 4 plus I sin pi by 4 whole to the power n, that is equal to c0 minus c2 plus c4 minus so on plus I c1 minus c3 and so on. So we can write that 2 to the power n by 2 is into cos n pi by 4 plus I sin n pi, this should be I n pi, there is an n missing, I n pi by 4 is equal to c0 minus c2 plus c4 and so on plus I c1 minus c3 plus c5 and so on. Now we equate the real part, we get c0 minus c2 plus c4 minus c6 and so on is equal to 2 to the power n by 2 cos n pi by 4. Now we add this result with this, so we get 2 into c0 plus c4 plus c8 is equal to 2 to the power n minus 1 plus 2 to the power n by 2 cos n pi by 4. So after that you divide from 2 both sides, it will get cancelled and it will become 2 to the power n by 2, n minus 2, and this will become 2 to the power n by 2 minus 1. So that's how we get the desired result. Question 314 says that solve the equation z to the power 8 plus 1 is equal to 0 and deduce that cos 4 theta is equal to 8 into cos theta minus cos pi by 8 into cos theta minus cos 3 pi by 8 into cos theta minus cos 5 pi by 8 into cos theta minus cos 7 pi by 8. So we are given that z to the power 8 plus 1 is equal to 0. So z to the power 8 is equal to minus 1, and minus 1 is nothing but cos pi plus I sin pi. So z becomes cos pi plus I sin pi to the power 1 by 8, which is equal to cos 2r pi by 8 plus pi plus I sin 2r pi plus pi by 8, where r varies from 0 to 7. So we get z as cos pi by 8 plus minus sin pi by 8, cos 3 pi by 8 plus minus sin 3 pi by 8, comma cos 5 pi by 8 plus minus 5 pi by 8, cos 7 pi by 8 plus minus sin 7 pi by 8. Now the quadratic equation whose roots are cos pi by 8 plus minus sin pi by 8 is z square minus 2 cos pi by 8 z plus 1. What you have to do is you take alpha is equal to cos pi by 8 plus sin pi by 8 and beta is equal to cos pi by 8 minus I sin pi by 8. There should be an I here. I is missing. So the equation would be z square minus alpha plus beta z plus alpha beta. That would be z square minus 2 cos pi by 8 z plus 1 is equal to 0, because these are conjugates. So z bar is equal to mod z square. So modulus is 1. So alpha beta would be 1. So similarly, for other values of these, we can find the quadratic equation. So what z to the power 8 will look like is z to the power 8 plus 1 is equal to z square minus 2 cos pi by 8 z plus 1 into z square minus 2 cos 3 pi by 8 z plus 1, z square minus 2 cos 5 pi by 8 z plus 1 into z square minus 2 cos 7 pi by 8 z plus 1. So we divide both sides by z4. So left hand side becomes z to the power 4 plus 1 by z to the power 4, and right hand side becomes, so we divide this by z, it becomes z plus 1 by z minus 2 cos pi by 8. We divide the second term by z, it becomes z plus 1 by z minus 2 cos 3 pi by z, and so on. So these are the two other terms. Now if you substitute z is equal to cos theta plus I sin theta, z to the power n plus 1 by z to the power n is equal to 2 cos n theta. How? Because if z is this, z to the power n will be cos n theta plus I sin n theta. And z to the power minus n, that is this term, that will become cos n theta minus I sin n theta. So I sin n theta will get cancelled with minus I sin n theta. And cos n theta will get added with cos n theta, giving us 2 cos n theta. So from this equation we get 2 cos 4 theta is equal to 2 cos theta from here, okay, cos theta minus cos pi by 8. 2 we have taken out as common, and 2 we have taken out from the second term as well. So it is cos theta minus 3 pi by 8 into 2 into cos theta minus 5 pi by 8 into 2 into cos theta minus 5 pi by 8. Now this is 16, 2 2 ja 4, 2 ja 8, 2 ja 16. So we divide from 2, we get 8, and rest of the terms follow. And that's how we have proven the required result. Question 315 says that prove that the roots of the equation 8x cube minus 4x square minus 4x plus 1 is equal to 0 are cos pi by 7, cos 3 pi by 7, and cos 5 pi by 7. So we let z is equal to cos theta plus I sin theta, then z to the power 7 is equal to cos 7 theta plus I sin 7 theta. So theta is equal to pi by 7, 3 pi by 7, 5 pi by 7, 7 pi by 7, 9 pi by 7, and so on. Now z to the power 7 is equal to cos 7 theta plus I sin 7 theta. That is z to the power 7 plus 1 is equal to 0. Now since z is equal to cos theta plus I sin theta, where theta is equal to these values, are the roots of the equation. Okay, so we say that these are the roots of this equation. Also, when theta is equal to pi, z is equal to -1. So z to the power 7 is equal to z plus 1 into z to the power 6 minus z to the power 5 plus z to the power 4 minus z to the power 3 plus z square minus z plus 1 is equal to 0. Now roots of this equation, z plus 1 is equal to 0, is cos theta plus I sin theta, where theta is equal to pi. Roots of this equation, the second term, is r cos theta plus I sin theta, where theta is equal to these values. Okay, so we let x is equal to cos theta, then z plus 1 by z is equal to cos theta plus I. This is, there is something wrong here. This should be z is equal to cos theta plus I sin theta. So z plus 1 by z is 2 cos theta, like previous problem I have explained this, is equal to 2x. Oh, it's okay. This is x is equal to cos theta. If you take, then that z plus 1 by z is equal to 2x. But cos 13 pi by 7 is nothing but cos 2 pi by 2 pi minus pi by 7, that is cos pi by 7. Similarly, cos 11 pi by 7 is cos 3 pi by 7, and cos 9 pi by 7 is cos 5 pi by 7. So we divide this equation by z cube. We get z cube minus z square plus z minus 1 plus 1 by z minus 1 by z square plus 1 by z cube, okay, is equal to 0. Now this becomes this much. That is, we have taken z cube and combined it with 1 by z cube. We have taken z square, combined it with 1 by z square. We have taken z and combined it with 1 by z. So this entire thing becomes z plus 1 by z whole cube minus 3z into 1 by z into z plus 1 by z minus z plus 1z whole square minus 2z into 1 by z plus z plus 1 by z is equal to 0. So this becomes 8x cube minus 4x cube minus 4x plus 1 is equal to 0, because we substitute z plus 1z is equal to 2x from here. So roots of this equation are cos pi by 7, cos 3 pi by 7 and cos 5 by 7, as we have deduced from here. Question 316 says that solve the equation z to the power 10 minus 1 is equal to 0 and deduce that sin 5 theta is equal to 5 sin theta into 1 minus sin theta by sin square pi by 5 into 1 minus sin theta by sin square 2 pi by 5. So we have z to the power 10 is equal to 1 from the given equation, which is equal to cos 0 plus I sin 0. That is, z is equal to cos 0 plus I sin 0 whole to the power 1 by 10. This should be 1 by 10. So that is equal to cos 2r pi by 10 plus I sin 2r pi by 10 is. So that implies the roots of this equation are plus minus 1 cos pi by 5 plus minus I sin pi by 5, comma cos 2 pi by 5 plus minus I sin 2 pi by 5, cos 3 pi by 5 plus minus I sin 3 pi by 5, and cos 4 pi by 5 plus minus I sin 4 pi by 5. Now quadratic equation whose roots are plus minus 1 is z square minus 1, and quadratic equation whose roots are cos pi by 5 plus minus sin pi by 5 is z square minus 2 cos pi by 5 z plus 1 is equal to 0, and so on. So like one of the previous problems, z to the power 10 minus 1 will become z square minus 1 into z square minus 2 cos pi by 5z plus 1 into z square minus 2 cos 2 pi by 5 into z plus 1 into z square minus 2 cos 3 pi by 5 z plus 1 into z square minus 2 cos 4 pi by 5 into z plus 1. Now we divide both sides by z to the power 5. So our left hand side becomes z to the power 5 minus 1 by z to the power 5. And we divide this by z, we get z minus 1 by z. We divide this by z, we get this. And so on. Now if we put z is equal to cos theta plus I sin theta, we will have z to the power 5 minus 1 by z to the power 5 is equal to 2i sin 5 theta. So 2i sin 5 theta we substitute here. Okay, this becomes equal to 2i sin theta, that is the value of this from this. Okay, we substitute 2i sin theta from here. Okay, and because z to the power n minus 1 by z to the power n would be 2i sin n theta, and similarly we substitute for these also. So we arrive at sin 5 theta is equal to 16 sin theta cos theta minus cos 5 pi by 5 cos theta minus cos 2 pi by 5, cos theta minus cos 3 pi by 5, cos theta minus cos 4 pi by 5. So what we do is we rewrite this, and this becomes 16 sin theta cos theta minus cos pi by 5, and then we take this cos 4 pi by 5, that is equal to cos pi minus pi by 5, that is minus cos pi by 5, minus minus becomes plus, that is equal to cos pi by 5. And similarly these two terms become conjugate of each other. This is cos theta minus cos 2 pi by 5, and this is cos theta plus 2 cos 2 pi by 5. So right hand side becomes 16 sin theta cos square theta minus cos square pi by 5, cos square theta minus cos square 2 pi by 5. This becomes sin square pi by 5 minus sin square theta into sin square 2 pi by 5 minus sin square theta. So we take out sin square pi by 5 and sin square 2 pi by 5. This becomes equal to 1 minus sin square theta by sin square pi by theta, 1 minus sin square theta by sin square 2 pi by theta. Now sin square pi by 5 is sin square sin 36 degree, and sin 2 pi by 5 is 72 degree. So now it is a matter of simple putting the value and solving, and we have the desired result here. Okay. Question 317 says that solve the equation x to the power 7 plus 1 is equal to 0 and deduce that cos pi by 7 cos 3 pi by 7 cos 5 pi by 7 is equal to minus 1 by 8. So we have x to the power 7 is equal to 0. So x to the power 7 is equal to minus 1, that is cos pi plus I sin pi. So proceeding like previous problems, we deduce roots to be cos pi by 7 plus I sin pi by 7 cos 2 pi by 7 and so on. Okay. Now x to the power 7 plus 1 like previous problems becomes x plus 1 x square cos pi by 7x plus 1 x square minus 2 cos 2 pi by 7x plus 1 and so on. Now I put x is equal to I here, it becomes I to the power 7 minus 1 is equal to 1 plus I into minus 2i cos pi by 7 minus 2i cos 2 pi by 7 and so on. So it becomes this I to the power 7 will be I to the power 4 into I to the power 3, that is 1 into I to the power 3, that is minus I to the power 3 is I square into I, so I square is minus 1 and I will remain here, that is equal to 8 into 1 plus I cos pi by 7. We multiply all this. Okay. So I cube will become minus I, and we will have this value. Okay. Yeah, there should be an I here. Yeah, there should be an I, that is equal to minus 8 into 1 minus I. Yeah, so it comes into picture, and there is a typing mistake here. Cos pi by 7, 2 pi by 7, cos 3 pi by 7. So from this and this we can deduce that cos pi by 7 cos 2 pi by 7 cos 3 pi by 7 is equal to minus 1 by 8. Form the equation whose roots are cot square pi by 2n plus 1 comma cot square 2 pi by n plus 1 and so on cot square n pi by 2n plus 1, and hence find the value of cot square pi by 2n plus 1 plus cot square 2 pi by n plus 1 plus so on up to cot square n pi by 2n plus 1. So we know that this is basically a binomial expansion, so you have to study binomial expansion to understand this problem fully well. It's moderately difficult problem, so you might want to skip this problem if you have not studied binomial theorem. So cos alpha plus I sin alpha to the power n is equal to cos n alpha plus I n c1 cos n minus 1 alpha sin alpha plus I to the power 2n c2 cos n to the power n minus 2 alpha sin square alpha and so on I to the power nn cn sin to the power n alpha. Okay. There seems to be some mistake. Okay, I am reading it wrong. All right. This is cos n to the power n alpha plus I into nc1 cos n minus 1 alpha sin alpha plus I square into nc2 cos n minus 2 alpha sin square alpha plus and so on plus I to the power n into ncn sin to the power n alpha. So cos n alpha plus I sin alpha from left hand side is equal to cos to the power n alpha minus nc2 cos to the power n minus 2 alpha into sin square alpha plus I into nc1 cos to the power n minus 1 alpha sin alpha and so on. There is typing mistake here. There should be plus and then triple dot. So by comparing the imaginary parts, we have sin to the power n alpha is equal to nc1 cos to the power n minus 1 alpha sin alpha minus nc3 cos to the power n minus 3 alpha sin cube alpha and so on. So therefore we put alpha is equal to 2n plus 1. We put n is equal, in place of n we put 2n plus 1. So this becomes sin 2n plus 1 alpha is equal to 2n plus 1 c1 cos 2n alpha cos to the power 2n alpha sin alpha minus 2n plus 1 c3 cos to the power 2n minus 2 alpha sin cube alpha and so on. So left hand side is sin to the power 2n plus 1 alpha, and then we take out sin to the power 2n plus 1 alpha common. So our terms inside bracket becomes 2 to the power n plus 1 c1 cot 2n alpha minus 2n plus 1 c3 cot 2n minus 2 alpha plus so on, where alpha is pi by 2n plus 1, 2 pi by n plus 1 and so on. So sine to the power 2n plus 1 alpha, sorry, not power, sine 2n plus 1 alpha is equal to 0. Therefore, these are the roots of the equation. Now from the second term, coefficient, that is second term coefficient is this. Second term coefficient, I'm not sure where we get. Oh, from the second term coefficient we get this sum of roots in a polynomial. This is the Vieta's relation we are talking about. So suppose there is a polynomial like a0 an x to the power n plus n minus 1 x to the power n minus 1 plus n minus 2 x to the power n minus 2, then sum of roots is given by minus a to the power n minus 1 by a to the power n. That is what we are talking about, that from the second term coefficient we get sum of roots in a polynomial, and that's why this sum would be equal to minus 2n plus 1 c3 by 2n plus 1 c1, and that's what we needed to find out. Question 319 says that if theta is not equal to k pi, show that cos theta sin theta plus cos square sin 2 theta plus so on up to cos to the power n theta sin n theta is equal to cot theta into 1 minus cos to the power n theta cos n theta. So we let c is equal to cos theta cos into cos theta plus cos square theta cos 2 theta up to cos to the power n theta cos n theta, and s is equal to cos theta into sin theta plus cos square theta sin 2 theta plus up to cos to the power n theta sin n theta. Now c plus is will become cos theta into cos theta plus I sin theta plus cos square theta into cos 2 theta plus I sin 2 theta up to cos to the power n theta into sin n theta plus I sin n theta. Now this is equal to cos theta plus e to the power I theta plus cos square theta into e to the power 2i theta and so on up to cos to the power n theta e to the power n I theta. This is equal to x plus x square plus up to x to the power n, where x is equal to cos theta into e to the power I theta. We find out the sum of this geometric progression as x into x to the power n minus 1 by x minus 1, that is cos theta into e to the power I theta into cos to the power n theta into e to the power I n theta minus 1 divided by cos theta e to the power I theta minus 1. Now this we rewrite as cos theta into cos to the power n theta cos n theta plus I sin n theta minus 1 divided by cos theta in the minus e to the power minus I theta. That is, we divide by e to the power I theta, the numerator and denominator, and we expand e to the power I theta in the numerator. So this becomes cos theta into cos to the power n theta into cos n theta minus 1 plus I cos to the power n theta sin n theta divided by cos theta minus I sin theta. So this becomes equal to minus I cot theta cos n to the power n theta cos n theta minus 1 plus I cos to the power n theta sin n theta. Now we equate the imaginary parts. So that is, this will become equal to s. So we get s is equal to minus cot theta cos to the power n theta cos n theta minus 1. That is cot theta into 1 minus cos to the power n theta into cos n theta, which is what was asked from us. Question 320 says that show that minus 3 minus 4i is equal to 5 to the power e to the power I into pi plus tan inverse 4 by 3. So we represent this in polar form by taking out the modulus. So modulus of 3 and 4 is 5. So we take out 5. It becomes minus 3 by 5 minus I 4 by 5, which is equal to 5 into cos pi plus tan inverse 4 by 5 plus I sin pi plus tan inverse 4 by 5, which is equal to 5 into e to the power I pi plus tan inverse 4 by 5. So with this we come to the excuse me. With this we come to the end of 33rd set of problems on complex numbers. There are few more sets to go on and then we will end complex numbers. So I hope that you have found this video useful and informative. Please make sure that you smash that like button and share the video as much as on social media possible, and make use of the comment box to speak your mind and interact with me. I would like to interact with you guys as much as we can so that we can learn and grow together. Thanks a lot for watching. Have a nice day.